All right, I think we are live. Okay, I think we're back. We are back. I am unmuted. I am ready to go. We're back into designing once again. So let's see how we're gonna do this. Okay, so where we left off yesterday, for those who were watching, we were going through the whole concept generation for how this ping pong machine is going to work. Ping pong ball. So we're going to try to shoot a ping pong ball, and we're trying to figure out how to do that. Shit. Yes, I have it unmuted. I got that one. Thanks, Jack. I needed that. Shit. Alright, yeah. So we're going through the design of it. We have gone through the first 5 concepts. I got you lunch one day, Jack. I love you too. Goddamn. First donator, you'll be. Oh wait, hold on. I gotta fix that. Oh no, it's not popping up. Okay, well, the donation thing doesn't work, but I'll fix that later. Alright, so here we go. Let's see what we're gonna do. So yeah, we got through the different concepts on how to shoot the ball. We have this tennis ball mechanism, we have a spring-loaded mechanism, a fan shooter, and a catapult using a pump, and a gravity shooter. So, we also went through the live feedback system. What we can do is use a Raspberry Pi as well as its camera. I think we are going to stick with that simply because I already have those components already. And I don't really know any other way to do it. And then we went to the power source and transmission, 9-volt battery, wall outlet, DC power supply, and all the other, basically all these actuators that we have. So those are all our options. So let's just continue with the design. Is to store this ping pong balls. Let's see this. Alright, so that's our next goal. Let's see. Store ping pong balls. Oh, that's not it. Here we go. So, storing the ping pong balls. Here we go. So like an obvious solution would be having the ping pong balls to be gravity fed. So I'm thinking some sort of container, and then this goes out to an outlet which goes into the shooter. So that's a very obvious design. So that's how we're going to store them. So basically we just fill up a bowl with ping pong balls and let them fall out, or let them pass through the system one by one, which may be an issue because how would we control the ping pong ball going one by one? So we might need something more to that, but that might be dependent on the mechanism of shooting the ping pong ball, so we won't go into that for now. So we can just focus on storing the ping pong balls. Another way we could do it, you could think of it like a gun, maybe some sort of mechanism that is loaded or spring loaded, so we could have basically a cartridge with like a support. Maybe this is not a good way to show it. Let me see if I could draw it better. That's not how you do that. Let me see. How do I delete this? I guess you don't. That's great. There we go. So then another way we could load the balls into the gun or the ping pong ball shooter is by having a spring loaded system, which might be convenient for loading purposes. So what we can do is have basically a cartridge, something like that, and then we'll have the balls inside. So the width will be just enough for the ping pong balls to go inside, and then we'll have maybe, you know, a platform like that, and then we'll have the spring like that. So basically there'll be maybe a door or something that blocks this that is firm, and then as a ball goes out to be shot, oh, thank you 3Z482 for the subscription. Thank you for that. I appreciate the subscription. So essentially we'll have a mechanism like that to basically unload the gun or the ping pong ball, which can work. I don't see any issue. Again, these two have the same issue of having the discrete ball coming out like one at a time. So how will we control that? Maybe this is actually easier because we could have the wall be the width of a ping pong ball. So basically whatever causes this to move, we could just rely on the width of the ping pong ball to control how many ping pong balls go out at once. So maybe this is a better design. What else can we do? What else can we do to unload a ping pong ball? I'm gonna call this gravity fed reservoir. And then call this spring loaded clip. That's really what it is. It's just a clip. Loaded clip. How else would we send a ping pong ball? Yeah. Again, I'm trying to think of like analogies or things that we use on a day-to-day basis to figure out this one. If you guys have any ideas, feel free to let me know, because I don't have. It's good to brainstorm together. That's usually how ideas come to life, you know. I'm not sure what we could do besides that. Maybe. Yeah, that's it. I can't really think of much else. I mean, it really ends up being, I mean, whatever I come up with, like the general pattern is that we have some sort of space to store the balls, and then somehow make the ball go to a location of a place so we could actually shoot the ball. So it's not really, this one we're using gravity to move the ball into the right location. Here we're using a spring to move the ball to the right location. So I guess when it comes to storing a ping pong ball, we're trying to find that right mechanism to put the ping pong ball in the right place, as well as storing them. So besides that, I mean, we could look at our actuators or our power mechanisms that we have. We have strings, pulleys, fans, wheels. Yeah. I mean, I think these are two of the most simplest designs. I feel like there's more ideas, but I can't think of much more. So springs, pulleys, strings, chains, fans. I kind of do like the spring-loaded clip though. I think this is a lot easier to control than this. So, okay. I mean, I didn't expect that one to be really short, but I can't really think of much right now. So, let's hop on to the next one. Again, we could come back to these later if we have any ideas that come out when we start designing more things. I need to look at the camera more. I moved my camera to the side so it's not on my desk, so it won't be shaking when I write on my my tablet. So here we go. Sensors. Okay, we could go to sensors. Let's see what we could do with that. Sensors. Okay, so what kind of maybe we need to detect? We probably don't. This kind of goes with the reservoir. Detect when a ball is when a ball is ready to be shot. When ball to be shot. So that might be one. If you really want to get into like the whole environment game aspect of it, we could also put sensors in on the table or the cups or the whatever target we're aiming for. So we could put maybe some sort of RF sensor, so some radio signal. Maybe I really don't want, because like that's not really part of the shooting mechanism. So this is more of like a feature than the device for it to work. So there's that. We could also we could use ultrasonic sensors to detect how far a cup is. That may be useful for the user to determine how powerful to throw a ball. So ultrasonic sensor. So if you guys don't know what an ultrasonic sensor is, they typically look like this. They look like two little circles on a rectangle, and then you have like a power input, a ground, and then some sort of signal. So something that looks like that. And then basically these send out basically sonic signatures at some sort of frequency, and then it'll bounce off an object and then come back, and then using the time between the time it takes for the wave to hit that object and come back, it will determine how far the object is. So we could use that to determine cup location, which would be useful for the user interface if we were to look at this. So maybe you could aim at a cup, determine how far it is, and then from there you could enter your power input into the command. So we could probably do that. That may be useful. What else can we do? What other sensors might be useful? We could, color sensor. It kind of goes with the Raspberry Pi, maybe. So color. The reason why I say this, I think I was talking at last stream. I don't know if I was muted or not, but essentially what we could do is use the idea of color to detect when a game is over, at least in the perspective of the player. Because if you don't see any red cups, then you can assume that the game is over. So maybe to detect game time, I guess. I don't know what you would call that. Maybe halftime, when game's over, whatever you want to do with that? So that would be basically using OpenCV, some sort of detection algorithm that detects color. And then if you see red or don't see red, game is going on, game is not going on. So maybe we could use that. It's not. That's more of like a feature than making sure the ball or the shooting mechanism works. So maybe that's just an add-on. I should probably label these as features so I don't focus on them, because that's not necessary to get this project going. So this is more of a feature. Yeah. Oh yeah, thank you again. If you guys have any ideas, feel free to shout them out, because I'm open to hear you guys' thoughts. And like, you know, again, if you have multiple people thinking at once, more than likely a great idea is gonna pop out, or even just fixing something or solving a problem. It's really helpful. But yeah, feel free to chime in whenever you have a chance. Ball to be shot, RF sensor. What else can we use? Okay, if we were to shoot a ping pong ball. Oh, I guess this is kind of obvious. I guess it's not really a sensor, really, because it's more of an input that we're going to control. But I think it's a given at this point, is stepper motors. So it's determining location. I mean, you're kind of sensing it based off what the Arduino says. It's not really a sensor, it's more of an actuator, but we might need to determine location. So I'm pretty sure there's already a library or module within Arduino to tell you where, or at least how to calculate the position relative to where you are. To detect the position you want to go to relative to where you are now, if that makes sense. So yeah, so it's not really a sensor, it's an actuator, but we could use it. We could call it a sensor for now. Maybe we need to figure out how many cups or how many balls are left. Ooh, that might be fun for the spring-loaded one. I have an idea. What we can do for the spring-loaded one is we could actually have maybe some sort of, so like I'm gonna say like this is a metal contact. We'll ground this. We'll put like a metal contact, maybe a piece of aluminum foil or something, and then there'll be another contact over here, which will be, I don't know, at plus 5 volts. And then if we get a short, we can detect that the balls are gone. So maybe we could do that. For this one, we might be able to use some sort of pressure. No, not pressure sensor. I want to say weight, but then again, like ping pong balls don't weigh much. And so let's say we have 100 balls, right, in a cup or in a bowl. Like if we run out of balls to maybe 10 or so, if the sensor is not sensitive enough to detect a ping pong ball, it would say technically the balls are gone. So I don't want to use weight. A camera would be nice, because the ping pong balls, we could choose a very distinct color such as orange or white. But that requires another camera, and I don't think the Raspberry Pi can handle 2 cameras. Maybe it can, I'm not sure. Maybe the new version can do it. God damn it. Thank you, Liz Martinez, for 99 cents. Thank you for that. Again, I wish I had the donation up, but I don't. So that sucks. But this donation stays live or updated for as long as it's how do you say it? It always remains constant in terms of like the most recent updated. It doesn't change until someone else updates or donates. So you will be on there in the next stream once I fix that. So, but thanks again for the donation. I really appreciate that. I'll buy you a beer. All right, here we go. here we now I lost my train of thought. A purple cat. Yes, I could buy you a purple cat. Or I don't get it. I really don't. Okay. Anyway, back to the sensing how many balls are in a bowl. Sounds like an age-old question that can never be solved. Maybe we could. Maybe we have. Okay, this is a clever way. I think we could define the volume. Define some set volume, right? Make it a simple shape, maybe a cylinder or a box, right? We fill up the box with however many balls it has, and then from there, we count down the shots. Maybe through the Arduino, because we could, once we shoot a ball, we could sense that through the Arduino or something, and then based off that counter, we could detect how many balls have been shot. Therefore, we could detect how many balls are left, which could tell us to refill the ball. We could do that. So we could define the volume, how many balls, and then what? And then tell us to refill. So we could do that. I think that'll be a very easy way of doing this. The only problem is that if you don't accurately put the balls in, then, well, it doesn't work. So that's a problem. So yeah, I mean, so some sort of sensor to detect how many balls are left. I think that's the mainly what we're trying to get at. So sensor detect how many balls are. If you can't read my handwriting, I'm sorry. Balls are. So we can do that. What other sensor we might need? What if each one had an RFID tag as they came out and read out? Ooh, see, that's what I was thinking too. Like we could somehow modify the ball RFID tag. Are those like the NFC tags or whatever? I think I know what you're talking about. So what Jack's saying is that we should have some sort of tag on the ball, and then from there we could determine how many balls are there. Wait, hold on. Let me see this. Do we have something like that? So. Yeah, so. The only problem with that is I don't know if there's some sort of API or some sort of module that can determine that can connect to the Arduino. I'm pretty sure you can. I just don't know how you would do that, but we'll put that down because why not? It's not, again, more ideas the better. So if you guys don't know what RFID tags are, I'll show you an image of them right now. So we can put these on the balls, basically. This kind of goes together with that. So let's see. If I could bring this up. Oh. RFI. Okay. It looks something like this. I was actually talking about this today to my manager. He was talking about getting a doorknob, or not doorknob, a video camera for his house, like those stationary ones. I was telling him, like, oh, you could sense stuff with like these tags, and you could have it do stuff and make your house like smart. So I was talking about that today. But let's see. Overlays, displays, browser general. No, that didn't work. Okay, yeah, it did. Okay, so yeah, this is what Jack was talking about. So we can just put one of these and then somehow detect. Maybe it's just a frequency or a to just basically detect it. So if we could use an RF sensor, we could control the frequency that corresponds to this or this tag, and then we could use that to determine how many balls are left. So we could do that. Yeah, because we could actually like cut a slit in the ping pong ball and then just toss these in there. Yeah, add some weight, but it's negligible. So we could do that. I don't see why that can't be an issue, or that can't be a design. Let's see. There we go. Okay. So the balls to be shot, detect when that happens. RF sensor, ultrasonic sensor, color sensor, stepper motors, sensor detect how many balls are left, RFID tags. Yeah, I mean, that's pretty much it. I don't. Again, I like to see the visually, so maybe we could think of something as we look at these. Yeah, I don't know. I think that'll be it. Like the very basic concept of like this is probably going to apply to a lot of things, like this contact where, like a switch basically. Yeah, so I think that's it for sensors. We are going through this quite quickly, to be honest. So in industry, it takes like 4 years to get like a product going, and like the whole design phase takes like another 5 years. So okay, position control. Oh, this is actually fun. This is like a new this is going to be similar to like the shooting mechanism, like the different concepts of how to move the robot or the gun shooter or whatever you want to call it. So position control. We could actually probably buy some stock if it works in our design, so which is pretty useful. Position control. So what we can do, what I mean by position control is like having, so the robot I think is going to be stationary. Like if you're just going to put it on a table and then that base platform is never going to move. But we could have platforms above it to rotate it, and that's pretty much it, rotation. So what I was thinking is like have a base like this, right? Something like that. And so this is stationary. And then we basically have basically a tilt device, maybe some bearings or something like that. And then this might be connected to a platform that's above it. And then there'll be a motor out here. So this is a motor. And then we could use this to rotate it, which will rotate the platform in this direction. So that's like the first platform, but we also have to do it in the other direction, which is not that difficult, because what you can do is just make it attached to this, right? So it's kind of hard to see. Maybe I'll draw it out better. So this will be the platform. Right, and then this connects to the motor, which rotates the platform. I'm not drawing it any better, but basically you have tilt in this direction, and then on this platform you connect basically 90 degrees and repeat the process. So create another platform, right? Oh no, my brain hurts. I can't think that far ahead. How do you see it? So basically I want to rotate this way, right? And then I want to rotate this way as well. Not simultaneously. It could be one at a time. It doesn't matter because it's a linear movement, you know. If you twist this way, you could twist this way first and then go this way, or you could go like this and then twist that way. It doesn't have to be simultaneously. You'll get to the same spot regardless. So, god damn it. I've seen like several of these. You could buy these on Amazon. I just don't know how they work necessarily. Let's see. Oh, by the way, for those who are watching, I believe I'm gonna change my schedule because it was kind of naive of me to say that I'm gonna stream 5 days a week. It's actually a lot of work, because I want to make sure the YouTube content that is uploaded immediately after the stream is correctly modified, so the title's good, the description's good. I want to put timestamps in the live stream, so it takes time to go through the video, put timestamps and stuff like that. So, and I have work in the morning, and I try to go to bed around 9:30 or 10 the latest. So I'm gonna put Monday, Wednesday, Friday at 6:30 to 8:30 p.m. PT, whatever that stands for, Los Angeles time. So yeah. But, yeah. I don't know how this works. Let me see if I could find one. You guys could research with me if you guys want. So we'll do this. Alright, so it's probably called... I remember looking it up for RC car Arduino. Let's see. Camera. No, not that. This is guest account. Arduino car. Maybe this has it. I've seen it before. Huh. The other thing that we have to worry about when it comes to moving this thing is the wires, because we don't want them to get tangled, and then that'll be an issue. So, I don't know what it's called. Rotating camera. Arduino. Stepper motor camera. Nope. I don't know if there's actually a name for this. Stepper motor camera platform. God damn it. Okay. Arduino camera. Oh, maybe it's Raspberry Pi. Camera rotating platform. Yes, this thing. Let's see. So this is great because we could just buy this and this will save so much time. So, I mean, it'd be fun to build it, but again, why reinvent the wheel? That's one thing I've learned is don't reinvent the wheel when you could just buy it. Like $36 is expensive, actually. I mean, I guess I have $3 to go to it, so I mean, we can buy it. Maybe, I don't know. But yeah, we could probably use this. So they have some sort of. So this is what I was trying to get at. So we have rotation. Can I just? So we have rotation here, and then on this platform we have another rotating platform, and then from there we could just put the mechanism, the shooting mechanism, on the platform. Now to come and think about it, we're gonna need a lid on that reservoir. So if you don't have a lid, the balls are gonna fall out. Okay, let's keep that in mind. So let's go to Photoshop and make that note. So whatever reservoir we have to close it. I mean, that's if we're gonna rotate it, just to make sure the balls don't go out of place or we lose any. So we're gonna have to make sure that that works without issue. So we got 4. So let's put a lid. Just need lid. Right, we need that. Yeah. So let me try to draw that mechanism, because that was, I think this is probably the best design. The only issue that I think can come with it is like the center of mass of the object actually uh-oh. I realize my light is not on. I think I broke it. Well, I think I broke my light. That's great. Oh god. The funny thing about this light is, like, I bought a lot, like a light that goes above your camera, and it didn't come with the battery pack, but it also has an AC input. I didn't have a proper AC power or AC supply that connects to your wall, so I just jerry-rigged one. I don't do this. This is actually very unsafe, but this is what you do when you're in a crunch. You do something like this. You use Scotch tape and a little bit of soldering that could possibly short this whole thing. But yeah, this is what's powering my light. Just because I didn't want to buy a whole battery pack or anything like that. Oh, it works. There we go. Maybe need a hard reset. I should probably turn on my light. Okay, I'm gonna turn on my light. So yeah, don't do that. If you're ever doing anything electrical with the power mains, don't do that. I'm doing it because I'm fully aware of my safety. If I wouldn't do that to anyone else. But okay, back to what we're doing. So the platform looks like this. So we have a rotating platform, and then we connect basically something that looks like this. Maybe a little pin here. I'm still not drawing it right. All right, what I'm gonna do, because I don't want to deal with this, because I want to draw it accurately enough. What I'm gonna do is this. So let's save this image. Save. There we go. There we go. So this is what I was talking about. So we have all forms of rotation. So I think I'm dwelling on this a little bit. Can I guess? Okay. Let me do that. All right. So we have rotation. We have rotation in this direction, and then we could use this to rotate. So that's, I mean, I think this is the best design in terms of how to control the ping pong ball shooter. I don't know how else we would rotate it. We could use maybe, we're going to have to use a motor. I think across all designs, we're going to need a motor. So we need, well, more specifically, a stepper motor, so we can accurately control the position of the motor. So we're gonna need a stepper motor. I mean, the design doesn't stop here, because we also got to spec out the motor, which I think this one's highly dependent on torque, because the torque is dependent on how heavy the object is. So if we make the object, or the shooting mechanism, or whatever ping pong ball gun we make, if the object is too heavy and we rotate it, here's a little physics for you. We could, like, let's say we have this platform, right? We have this platform, and then we have our rotating system, and then this is our gun, right? So if it was, our center of mass is here, which might be fine, but at some point the center of mass will be farther away from the pivot point, and then this will cause basically the whole mechanism to tip over. So we don't want that, unless we make make the design base heavy. So we just maybe add weight. We could just add weight. I have like some 5-pound weights, free weights, and I could just put that at the bottom, and then we won't have that issue. So we could combat that. But in terms of the motor, we have to make sure the torque is large enough so that we can actually recover from being rotated too far back. So that's something to keep in mind. But the whole specking out of the motors is too specific at the point we are at now, because we haven't even chosen mechanism yet. So we're just doing concept generation, just any idea comes to mind, and and when we have all the ideas written down, we'll analyze every one, the pros, cons, and then choose the best design, and then hopefully start 3D modeling. So that's the fun part. I think 3D modeling is one of my favorite things to do, because I like to make it highly detailed for some reason, even though it's highly unnecessary, but it looks cool. So I don't know. Actually, well, I'm going on a side note. I wonder if I could show you this. Let me see. I want to show you this. This is back in the day. I was gonna make a video about this, about my 3D modeling thing I did. I want to keep the suspense because I want to show you guys what I made. Let me see. Do I have it? Please, please, please. Oh no, I might not. Oh. Current? Damn it, I don't. No, I wanted to show you guys something, but I guess I can't. iPhone. No. I might have accidentally deleted it, which sucks. Why? Why would I do that? Yeah, I might not be able to find it. No. Can I at least show you a picture of it? Let me see. Maybe not. Sorry, I got distracted with the 3D modeling. I wanted to show you guys something. I probably don't have it. No. Okay, last shot before I give up on this. Basically, I 3D modeled something pretty cool, and I just want to show it off. That's basically what I'm doing right now. Can I search this? Past year. Yeah, I think I lost it. Damn, I wanted to show it off. Well, I guess I'll keep the suspense and then maybe make a video about it. Damn, that sucks. Oh well. Okay, well, let's move on. I'm sorry for that. But anyway, back to position control. What other ways can we control the position? I really can't think of more than that. Okay, to move something, what do we got to do? We're going to need some sort of motor. We're going to... I guess this is the only way to do it, to be honest, because all we need is rotation, because the platform is stationary. How would we do this? If you guys have any ideas, let me know. There's probably 100 ways to do to move something, at least something stationary, but I don't know too many. unless it's like overly complicated, like we can use magnets and like control, like maybe we have like a current running through a coil and then have that create like a magnetic field, and then put like a magnet on this thing and then put it like on a slot or a rail, and then control the current in the coil, and then which controls the magnitude of the magnetic field, and then that will attract it or repel it. So, but that can be solved way more simple by using this mechanism that's on the screen. So, STU Jaden Smith, thank you for the subscription. I really appreciate it. I actually really do appreciate your guys' support. This is great. Let me know if the alerts are too loud. I think they are, so I'm gonna turn them down a little bit. So yeah, okay. I mean, what we can do is go to my favorite website, at least in terms of an engineer. One of my favorite websites is Pornhub. No, it's McMaster Car, because it shows the full catalog of what we could potentially use. So if we do this, so this website is basically the bread and butter of all mechanical things. You could just go to this website and find practically anything that you need. So the cool thing is that they have a category for stuff, and they categorize things pretty well, which I appreciate tremendously. So yeah, so we're gonna probably look in the power transmission again. So we have some sort of linear actuator. I guess we could have a rail system. Well, no, that's XYZ. No, that's only translational movement. We need rotation. So what I mean by a rail system, if I show you guys, by a rail system, is so maybe you can think of it as a 3D printer. If you've ever seen how those things operate, we could just have like a rail for this. So it's like a slot. Something like this, I think. I have like a T shape so we could latch it. Oh, this is not looking good at all. I drew this completely wrong. I don't know what I'm looking at anymore. We could use a rail system. I think it's better. At some points, I think it's better just to look up an image. So let me try to do that instead. So 3D printer. Yeah. Images. This one doesn't show it because the bed moves. You can kind of see it here. There's a rail going along this axis, and then there's a rail on the side to move it back and forth. And then that's how you get XY translation. But again, we need rotation because the robot is going to stay stationary. To be honest, I don't know many ideas besides the ones we already have. Rotation devices. I mean, we could put this thing in like water and like somehow tilt the thing within water by using like the buoyant force or something. But that, again, that's just over complicating a thing that's already been done, which is unnecessary. Yeah, I think I'm gonna call this good because like this is bound to be the mechanism we're gonna use. So again, just because we said this, we still don't know which one we're gonna buy. We still gotta spec out all these things. So like, again, we need a stepper motor that can handle the weight of the machine. Spec out. So this is definitely our option. I think, because we don't have any other ideas. At least, again, if you guys have any ideas, let me know. Okay, so we finished that. Okay, so we gone through the position control. The last thing is the AI. Okay, the AI, or when I say AI, it's not really artificial intelligence. It's going to be something really dumb. It's going to be like a random number generator, and then whatever random number output, that somehow is going to correlate to the the gun or the ping pong ball shooter to rotate and shoot the ball. That's it's probably what's going to end up being. I could spend more time on it. I don't know too much about AIs, or how how they fundamentally work. I mean, I watch a few documentaries here and there, but nothing too surprising that I know. So again, this is more of a feature. It's not a necessary thing. Again, we want this to be controlled over the internet, so you, the viewer, can go in the chat, type something, type a command, or go on Twitter and tweet at me or something like that, and then that command will be sent to the robot, and then that will control the robot and shoot the ball. So that's the main goal of this. The AI, again, is just a feature, so we could do that later, but it's good to have it. If we're going to implement it, if we're going to try to implement it, we should at least go through it, because our mechanism might be dependent on it. So AI/PC player. Okay. So how we're going to do this, we could have some complicated AI. We could probably do it within the Raspberry Pi. I think that'll be useful. Or I could connect my laptop to it. I don't know. Some complicated AI. Probably some, I don't know if this is even the right terminology, but a neural network. It's more of like a buzzword for me. I don't really understand what necessarily it is, but we can maybe do that. Or we could do the random number generator. And like, I don't think it's that bad of an idea to do this. It's just like, if we were going to make the PC player or the robot to have some sort of difficulty setting, we're going to have to use some sensors to make it smart. It can't be smart on its own. Or I think I said that incorrectly, but I think you get the point. So random number generator. What else can we do for an AI? If we use sensors like to detect the cups, then we could sensors to detect cups. We could use probability. Probability or chance to shoot the ball. So, assuming an ideal system, like if you shoot the ball, it will go in the exact spot that you're aiming for. In an ideal system, if we could probably, what we can do potentially is that if we could detect the cup, we know its location. And if we, so I'm gonna call this the bot, and this is the table. If we could detect the location of the cup, or the nearest cup, I guess, what we can do, so if we detect this location, if we detect that location, we could from there determine how hard we need to throw the ball. So ideally it goes in an arc, but the horizontal velocity is the one that determines how far the ball goes. It doesn't matter how high you throw a ball, how far it goes depends on the horizontal throwing action or horizontal force. So by knowing that, by knowing the distance from the cup, we could basically give, an error to this. So this could be our error. All right. looks like a Q. I'll just call it E. So we could basically, if we want, let me draw this. So if you want a hard difficulty, the bot is more accurate, right? So this will be like a hard difficulty, right? So basically, you know the distance, and then you do like a random number generator from there, and that'll be your deviation from the ball. The larger the deviation, the easier the opponent is, meaning they're more likely to miss the cup. The smaller deviation would make player harder, meaning they're more accurate, more likely to make the cup. So we could do something like that if we had sensors, if we could detect the location of the cup. And this is where like the ultrasonic sensors can come to play. I spelled sonic twice. Sensors. So you can do something like that. I mean, that'd be cool. What else can? Okay, I'm thinking of beer pong. By the way, this is the game we're gonna end up playing one day. I'm assuming sometime next year. It's gonna take a while to build this. I know that for sure. But again, we just went to the first stream and we were halfway through this, and now we're on a second stream and we're still another halfway through this concept generation. The next stream we're probably gonna go through selecting and optimizing the selection and see which one is gonna be the best one. But yeah, it's gonna take some time. But in goal, we're gonna play some beer pong, and it's gonna be badass. Like it's gonna be cool. I'm gonna make sure it's cool. But or it might not never work. It might, yeah. To be honest, sometimes designs don't come in fruition. They just end there. But I think this is a feasible goal. But so if that's the end game, what kind of difficulty comes to play? Definitely environment comes to play. Like if you've ever played the game, if you put water in the cups or any kind of liquid of your preference, when you shoot a cup, more than likely it's going to be splashing. So there's going to be wet floor or wet table. Don't play this on the floor. A wet table. So that could change the difficulty. That could also affect the sensors, also the AI capacity of it. Someone's bound to spill a drink. So it's, now the environment comes to play, and that's where the practicality comes in. So that's like, we can't like hindsight's 20/20, right? We could try our best to predict it, but once we actually use this device, we're gonna learn a lot. So anyway, so if we're playing this game, what other difficulty comes to play? Size of cup, maybe, but that's not depend on the mechanism. Like, what can the player do to make the game harder? Like, we could make the robot be a jerk. Again, this is more of a feature, but we could, like, I don't know. Well, it has like it could have. I mean, this is obviously unnecessary completely. We could have like an arm over here, and it's like a backboard, and it just what do you call it? It just waves in front of the cups of your cups, the opponent's cups, or like there'll be cups here. I mean, that's just, again, this is completely unnecessary. But we could increase the difficulty that way. Maybe there's some sort of I would say that's against the rules technically, as long as the robot doesn't hit the ball. But like what I'm thinking is something like this. Process guess. It's called Stupid Box. I forgot what it's called. Arduino. Useless box. Can we play this? So oh Jesus. So something like this. But instead of it being this robot, it's gonna be like a platform that like pokes out. Like it's basically taunting you. That could increase the difficulty, right? I mean, it's not against the rules. You could definitely do that. So that's what I'm thinking here. So imagine the same concept with this arm. It'll just pop in and out. maybe that's a difficulty setting. So arm blocking. So we could do something like that. What else can we do? We can make it distracting. Actually, why does it have to be physical? It could be mental, right? We could again, I'm thinking about how I play games of of uh of beer pong. It could be completely psychological, right? I mean, we could add a speaker. We could add a speaker. This is where it kind of gets ridiculous. Actually, that might be fun for you guys. Like, if we were to make this interactive over the internet, how you guys are gonna control it with like Twitter and stuff like that. What you guys could do is send messages through the speaker and then taunt me or whoever you're playing against, which is probably gonna be me. So what we could do is put like a speaker. Yeah, that's actually a pretty fun idea. Again, a feature not completely necessary, but it'll be a fun feature. So we could do something like this, right? It just yells. I mean, what comes along with the yelling is like the timing of the yelling. Like you want to time it so whenever I about to shoot, it says something, right? So maybe we could detect when a ball is being shot. That goes with the camera. So well, let me rush this. Let me just fully define this idea. So player types. What about lights too? What do you mean by lights? Oh, you mean like flashing lights? Yeah, we could do that. Yeah, we'll put that down. Okay, hold on. Player types phrase. Player types phrase. Place through speaker. Plays through. So, place through speaker, right? And then we could time it somehow by using a sensor. So what we can do, yeah, or LED, yeah. And we could use some high-powered like floodlights. I actually do have some floodlights, so we could probably use that. I mean, I would have to hook up a relay to it and then control it, but we could potentially do that. Okay, wait, hold on. Place through speaker. Detect timing. Out of screen. Sorry about that. Detect timing. When to throw a ball. Okay. Yeah, so we could flash lights. That's not bad. We could do that. So flash lights. God damn it. It never does what I want it to do. Okay, flashlights, floodlights, LEDs. Floodlights, LEDs. Yeah, so maybe you could control like the signal of the light, so you could flash in bursts. A smoke machine with floodlights. What is this, like a party? We're trying to party over here or what? God damn. All right. We could put some strobe lights. We could do some floodlights. We could do a smoke machine. We could put a DJ in the back. God damn. Yeah, we could do a lot of things really. Floodlights, LEDs. You could throw us a flashbang. clearing out the table. We could do that. Goddamn. We'll put that down. Can we actually purchase a flashbang? That's the real question. Can we actually buy a flashbang? Well, the first thing that came up was the riots, so I'm assuming those are being used somewhere. Oh. No, I don't think we could just buy a flashbang. I believe there's some regulatory behind that. Can't just go out to go buy a flashbang. But yeah, I mean, we could use lights to flash the player. Again, this is going for the difficulty of it. Yeah, catch a live flashbang. Just go to one of the protests and catch a live one. Yeah, catch that in Corona. Goddamn. All right. So there's that. Again, I think we're straying off a little too much because this is not really the AI how it operates. It's more of just like difficulty. Because well, I mean, it's a feature, but then again, these do. If we were gonna implement these would affect the design. So, I don't know what else we could do for the AI or the PC player. Yeah. I don't know. Yeah, I mean, that's all I. Oh, and by the way, what I mean by PC or players, like, if you don't have anyone to play with, you could just turn on a robot and play beer pong by yourself, or whatever cup game you're playing with a ping pong ball, by yourself, which is kind of funny, kind of sad to be honest. But in these times of coronavirus, you may need that one companion that is powered through a wall outlet. Okay. I think that's it. Um it'd be kind of cool. I mean, it's only for me to see really, but maybe we could put like a gamer tag on this thing. Like we could put like a little what do you call those things? Like a 7-bit display or something that basically just goes across. Like if you see on the bottom of the screen, you see people's names scroll. We could put that on the robot, and it could, say like the player's name or like the Twitter handle or the stream handle that you guys have, and we just display that. But like that's only for me, really. You guys won't be able to see that unless I make a video about it or something like. So that may be cool. We could put that down potentially. Again, these are more features. It's not really necessary. So, gamer handle. Gamer handle display. So like, let me just draw it out so I don't forget what I mean. So we'll have something like this, and then we'll just have the scrolling text going that way, and then it's the gamer tag. So something like that. I mean that's I think we're kind of exhausting all these ideas with the whole AI PC thing. But again, we could come back to this, put more into it, because I feel like most of these things are going to be features than it is actually to get this PC player to work. So we could come back to it later. I don't think it'll affect the design that much. So I think, is that it though? I think did we reach all 9? Well, I guess we did. I mean, it's actually fairly quickly. I think we have a lot of ideas to choose from. So, control through the internet. So let's just briefly recap it for those who haven't seen the last stream. So our design goal is to make a ping pong ball shooter. And then what I wanted to do is have it controlled over the internet, so that you guys could play some games with me. And how we're going to control that is usually through some sort of social media platforms such as YouTube, Twitter, Twitch, or whatever. From there, you guys type in a command, and then that command is sent to the robot, and the robot will determine the position or how far you want to throw the ball, and then the ball will be shot in turn, and then, the next step. So that's the whole goal. That's like the main goal of this project. So that's what the second thing is. We want to control through the internet. We're going to have special commands to rotate the robot or shoot the robot. So there will be a camera, so you guys could look for the location of the cups. So this is what this looks like right here. There'll be graphical displays on the camera. It'll mostly be done in HTML or CSS, whatever you want to call it. It'll just be a little browser, and then I'll just use that to stream, or I'll use that capture to stream on the actual live stream, and then go from there. And then you guys could control the power. You guys could see how much power you want to throw the ball, and then how to rotate the robot in terms of its vertical and horizontal axes. So that's that. That's how the camera thing. So again, this is the flow of information, or the workflow. You send a signal to the API. The API, whichever API we use, Twitter, YouTube, whatever, it goes to the Arduino. The Arduino sends a signal to our actuators, which is more than likely going to be motors, some sort of motor, maybe some ultrasonic sensors, stuff like that. And then will be sent to the motors in parallel, meaning they'll go to all the motors at once, so they do what they're supposed to do before the ball is shot. And then once they do that action, it'll tell the robot to finally launch the ball. That's a very basic algorithm of how this thing will work. And then we went to the different shooting mechanisms. So these are like the different designs we came up with. So this is just how to shoot the ball. There's many ways to shoot a ball, obviously, but choosing the right one or choosing the best one is when we have to come and analyze each one. So we have like the tennis ball shooter. Basically, we have 2 wheels. You can think of it like a Hot Wheels track or a legit tennis ball shooter. If I could show that, I think. I mean, you guys probably already know what this is, but why not show it? Let's see if I could find one. Oh, this is perfect. Let's see. Nope, don't do that. Wait, what? Nope. I'm sorry. Okay, it's not working. Okay, there it is. We could look at this. This one's really overpowered. I mean, they're launching tennis balls, so probably that's why they need a big... They're using lithium-ion batteries, too. That's some major juice. But this is basically the concept. You just you just launch one of those things. Oh, well, that's something to take in the design. If we're gonna use this, the wheel should be curved so it fits the concavity of the ball. I didn't consider that. But yeah, that actually makes sense because we could stabilize the ball uh, to shoot straight, basically. Um, and then also we could add like a little rail to the end of it, so something like this to guide the ball straight. Um, Maybe one thing to worry about, if we make the tube or the rail too long, it might slow down and decrease the speed, and therefore decrease the distance the ball is thrown. And to be honest, all that is going to be actually testing the device, because I can't. I mean, we could do the math behind it, but it's probably not worth it unless it's very simple. If we make it very simple and idealistic, then we could do the math. But if it's not, then we're just going to test it. And then we have the spring-loaded shooter. This one's pretty fun. I think this is pretty cool. We have a spring and then like some sort of piston or pin, and then it gets retracted by this plate, and then this plate is connected around a pulley and a string. I drew it as a gear and a chain. That's unnecessary. It could be a string and a pulley, and it wraps around a motor. So basically, it wraps around the motor, pulls this spring back, and then, oh, how would you let go though? I didn't think about that. How would you let go? We'll probably need another mechanism to let it go. Um, I didn't really think much of that. Maybe we could put this. Maybe what we can do is put. You put like a motor here, a little small motor, so that it could rotate forward, which will release the latch and then launch the ball. So this thing will look something like this, maybe. So something like that, and then this will be rotating that way or something. And then they'll release the latch, and then the spring can go. How would you reload it though? Now I'm lost for words. I don't know. Maybe magnets are better in this situation than a string and motor system, string and pulley system. Okay, I didn't think about that, but potential design, we'll figure that one out. Okay, we got a fan shooter. We just use a fan and a tube. Basically, control how far the ball is going to be shot is how fast the fan is going. I don't know how accurate that's going to be. I feel like there's going to be a lot of error with this one, but it is an option. We have a catapult. We're with the catapult. It's a very simple design, but reloading the ball is going to be an issue, and we're limited in terms of rotation, or position to throw the ball, because we have to make sure the thing retracts and expands, so that we could change the length of the arm, which will also change the speed of the ball. So we have to account for that. So it's not just the speed of the motor. Jesus. Okay. The more I'm looking at these, the more I realize the design is very rough. The pump air shooter, we have a pump. I drew a handle. It doesn't have to be man operated. We could just flow the air into the reservoir, into a check valve. The check valve prevents air from flowing back into the pump. And then we have a valve here. We close the valve to store high pressure. We inflate it, basically, and then we release the valve. The valve will let the air go out and push the ball. That's that. Then we have the gravity shooter. This one's like so archaic in terms of design, but basically we have like an elevator to lift the ball and then put it on this platform, and then it'll just roll off the ramp. So that'll do it. I realize I have a lot of dirty clothes in the background. Oh well. And then we just to change the speed of the ball or how far the ball will be going, we just change the height of this, which changes the velocity of the ball. So those are the different options. We have the live video feedback. Again, I want you guys to interact with this. We were talking about this earlier in terms of how we're going to control it through the internet. Power source and transmission. We need a power source to operate this whole thing. 9-volt battery can be an option, but there's no need for that. Again, simply because a 9-volt battery is made to be mobile. Our system is not going to be mobile. So why limit our power source when we don't have to? We use a wall outlet, create our own system to power the device. But a problem with that is that we need to create we have to rectify the signal into a DC signal, and that takes a lot of work. Again, why reinvent the wheel when we could just use a DC power supply? Again, we could be stationary and we don't have to worry about it. Or we could use those wall plugs, like what I'm using for my light. We could have basically use a 12-volt wall plug and then splice the leads and then use that as a power supply. So we could do that as well. And then we have our transmission, basically how the power is going to be transmitted to our system. We have motors, pumps, springs, pulleys, gears, strings, chains, fans. It's basically all the actuators within these designs. That's basically what all these are. Yeah. Then today we went through storing the ping pong balls. These are the different ways we stored them. I'm not going to go over that because we just did that. All the sensors, position control, we're more than likely going to use this unless we find another way of doing it, which I seriously can't figure out. AI PC player, we just got through this. So I think we finished that part, which is the rough design. But before we move on, let's just make sure we got everything. So what else does our system need? Not what we want, what we need. So we need to shoot it. We need to aim it. We need you guys to interact with it. So the user interface. Sensors, that kind of goes with interaction, AI. Yeah. I believe we got everything here. I don't know. Yeah. So I guess what we could do is move on to the next step, which would be basically choosing an option for each numbered item here. But before we do that, we should label out the most important things. So our selection, or how we choose the mechanism or the device we're gonna ultimately end up with, it's dependent on our choices. So order matters, essentially, in my opinion. Maybe it doesn't. We could, obviously it comes to the actual design, but from what I can tell, the root mechanism that's going to dictate all the other stuff is going to be probably the shooting mechanism. So we should choose that one first. To be honest, we could choose a power source too as the second one, but I think we could put this anywhere because we could get as much power as we want simply because we have a DC power supply as an option. So this one's very lenient, so we'll just get that second just to get it over with. I guess storing the ping pong balls will be the next one. Well, no. Well, it would be position control, but I kind of already accepted its fate. Because the position control, if we rotate the object, that might affect the ping pong balls. So, how we store the ping pong balls. Again, we don't want the ping pong balls to fall out of its reservoir. So, that could be an issue. Or that's how it's dependent on it. What else? I think then it'll be the live video feedback, right? Because why would it be next? How we stream the video will determine what platform we use potentially. And it's kind of a loose argument. But I think the physical aspect of how the live video feedback works, or the software works as well, it'll dictate which API. But I might be completely wrong with it. I feel like I'm wrong, but I feel like that'll be the fifth one. And then we'll put control to the internet, how we're going to control it, and then from there, maybe the AI, and then the sensors. Well, the sensors could go last, because if we need to sense anything, we could do that at the end. I think. Okay, I think that's it. If you guys have any other thought process, let me know. Let me see. So, what can we do? Okay, so let's just choose our shooting mechanism, go through the pros and cons. Okay, let's see if we could do this all on one page. Probably not, but we'll try. Maybe there's an easier way of doing this. There's not enough room. How much room do we have? Oh, I realize we're in the desktop view. So yeah, we don't have much. Oh, I guess we have some room. Can I do this? And then select that. Jesus. Select it. Oh. That's not what I wanted. It's a Control Alt J. Oh, it's locked. That's why. Jesus. Okay, here we go. Moment of truth. I guess we'll just do it on the side. That's fine. We'll do it here. Okay. Now we do this. And then this. Okay. Can I resize this actually? I'm sorry. I'm just, well, whatever. We'll just figure it out later. Okay, so pros. I don't want the pros and cons to be too generic, because it's not really too useful. Two motors. I think it's not accurate, relatively speaking. I need to back up my statement. I can't just say it's not accurate. Why do I think it's not accurate? I feel like unless we put if we put grooves, like how we saw in the video, if I still have that up, like if we put grooves in the system like that, then I think it'd be pretty accurate. But we would have to get a custom part for that. And I really don't want to get a custom part. I'd rather just buy like a toy car and then take off the wheel from there and then use that. Just because I could probably find one in my disposal, maybe, and then use that. So it's effective in terms of cost. So just because of that, it's not as accurate if we don't use the grooved ones. And I believe we're going to use a toy car or something, toy wheels to do this. Because then I have to 3D print it, or maybe we could use like a yo-yo. Maybe, I don't know. And then we have to make sure the diameter fits the shaft of the motor. And then at that point, I don't think it's worth it. So I'm gonna say this is least accurate, because I want it to, well, not least accurate, but not super accurate. So, toy wheels, something like that. I think that's where the accuracy comes into play. What else? We need 2 motors. Controlling is, I guess this is a con. It's not really a pro. So pros, it could be very simple to control because all we have to do is control the speed of the motor. So simple control. What else? I think what we're gonna have to do is make it a tube, because that increases the accuracy of the ball. We control. Now I just made it better, to be honest. I guess it's not a bad design. It's just, how would you build it? I'm thinking PVC pipe, just to launch it. So we just have like, I don't know, the reservoir here, and then it'll be fed it to the wheels, and then this would be launching it that way, and then this is like the tube. So this is the PVC. That's how I'm thinking of it. It's almost like a paintball gun or something like that. So if we use a tube, it's actually, I think, more accurate. Tube. Yeah, this is actually not helping, because technically all these designs could work. It's just choosing the best one. Hopefully cost is not the only factor that determines this whole thing. Not that I need the money. I'm just saying, like, I want the selection to be based off the design, not because of what we can purchase. You know what I mean? So yeah, I mean, it's a pretty good design. I mean, I don't know what other things can go wrong. Like, the ball could get stuck. That's a con, right? It could jam. It could technically jam. So, ball can get stuck, right? It can get stuck. Like, if we make the motors too close to each other, the ball can get stuck or not even go through at all. So, and then we might hit stalling torque for the motor, so the motors might just stop. So there's that. Ball can get stuck. What else can happen? We'll have to be precise on how the motors are oriented. Like, they could bow in a little bit, and that can cause an issue, maybe, or maybe it doesn't. Like, they could bow out, or we need them perfectly straight, ideally. So assembling it or making the part accurate or precisely is maybe an issue. But we can technically control that by putting slots around the shaft. And then we could use, like, I don't know, some sort of wall or some sort of mount to, guide the motor in and out to get that right spacing for the ping pong ball. So there's that. I mean, that's pretty much it. Again, if you guys see any flaws or any other redesigns, let me know. Yeah, I think that's. I'm trying to think of anything else that could go wrong. If you use PVC pipe, does it feel staticky? You know what I mean? Like, does that have an effect on the ball? Maybe, because the ball is really light. Like, you can think of it like friction. Well, friction won't matter because friction is technically dependent on the normal force. So what would that be? The weight of the ball, maybe, or the force the force of it being propelled. So, if the gap is too small, or if the PVC pipe is too small, but that's our fault. It's not the design's fault if we spec it out too small. I don't know. I can't really think of any. Like, I think the ping pong ball being light, its main opposing force will maybe be drag. Simply because the ball is light. It's like throwing, like, I don't know. I guess you can throw a ping pong ball really far, but I think it's more difficult because it's not as heavy as another ball. Okay, I'm just rambling. I think. Okay, I think we're good here. So I don't know. I'm gonna give this a rating out of 10. If you guys want to give a rating out of 10, feel free to put it in the chat because I don't know. If you want to see the contenders, or 6 contenders out of 10, I'd probably give this. It's a solid choice, right? If we have a PVC pipe, it's a solid choice. How about loading it? Would loading be an issue? No, because like we just need one ball at a time, and this restricts the ball, like how many balls can go through at once, right? Well, technically, I mean, we could probably rapid fire this if we really wanted to, which can be fun. But how would we load it? Well, again, that's dependent on the storing device. So maybe we should look at that. Is that number 2? No, number 2 is power transmission. We might actually move up the. Where is it? Where'd it go? Store several. We should probably move that to like 2, because now I feel like the mechanism is more dependent on how we load the ball. So we'll move that to 2, and then put this to 4. Okay, so that's kind of hard to tell which one. Well, if we choose this one, the spring-loaded one with the tennis ball shooter, if we choose that one, then what would happen? We would have to make it so that the motors are directly on top, which is kind of difficult because the motor would be spinning. Well, we could turn off the motors, right? We don't have to have the motors always spinning. We could, well, the reason why I say that's an issue, I'm just thinking out loud here. This is something you guys may or may not know, but let me draw out the concept. Essentially, we'll have a motor, something that rotates, right? All right, we have a motor. And again, the reason why I'm talking about this is because we don't want to turn off the motor initially. You'll see what I mean. So to get this motor going, it requires some sort of voltage or some sort of potential. So maybe the motor, there's probably a specific term for this. I don't know the specific term, however. But let's say the motor, to get going, you can think of it as your car. To get going, we need maybe, if this is spec'd out at max, I don't know, we'll say 12 volts. 12 volts max, DC. If it's spec'd out at 12 volts, the thing will rotate at 12 volts guaranteed. But it's an analog input, meaning it's not discrete, obviously. It doesn't mean it turns on only at 12 volts. It turns on at maybe 6 volts, 3 volts, or whatever. So let's say when the motor is stationary, I mean, we're going to deal with small motors, so maybe this is not an issue. No, actually it is. I've messed with small DC motors, and they actually have this phenomenon. So essentially, we'll say that 12 volts max, before it starts, causing extreme wear on the device, and before it starts failing or heating up too much. We'll say at like 3 volts. Oh no, not 3. We'll say 6 because it makes more sense. We'll say 6 volts to start rotating. Right? And I think it'll be helpful if I drew a graph. I like graphs. Let me see. So if we drew, so this is the voltage, and then this is the, I don't know, RPM in the rotation per minute. If we have that, you're gonna see how this all connects. Trust me. If we have this, to get the motor going, we need to be at 6 volts. So we'll say 6 volts. It will start rotate. Oh, I guess it's not. I guess I drew this inverted. Hopefully. 6 volts. Oh, I did draw this inverted. Okay, screw this. But it's the idea that if you hit 6 volts, it'll start rotating. that's the key. It'll start rotating. You'll hit a threshold, and then it'll start rotating. This is like the 6 volts. I guess I did draw it right. That'll be the 6 volts. Okay, I didn't draw it right. Okay, I'm probably confusing you guys. But essentially, if you start, the motor will start spinning at 6 volts, even though it's spec'd out at 12 volts max. However, you could draw, after the motor is already going, you could go down voltage, because now it's already in motion. It's using that concept of inertia to keep the motor going. So now, after you start rotating the motor, you could decrease the voltage and get a slower spin, a slower RPM. I mean, this concept is like when you drive your car. Like, you put it in first gear. That's a huge gear in your car, which means you have a lot of torque. The reason why you could relate torque to a force, just imagine it being a force. So the more torque you have means it gives you more power to move the car initially. And then once you gain speed, once the car gains momentum, you don't need that power anymore, or all that power to go to the car, because it's already moving. So, or you could just imagine it pushing a huge rock. Starting to push the rock is hard, but once you get going, it's easier. So you put less work in. But that's the concept. You're using like the concept of inertia to control the motor. So why that's an issue, if we come back here, is that if we use this mechanism to launch the ball, or this clip, or spring-loaded clip to launch the ball, the issue would be is that we'll have to go to the stalling or the voltage to start up the motor, which may be too high if the user specified a more fine-tuned power. You see what I mean? Like, if the user wanted to use 3 volts, they wouldn't be able to do that because the motor is stationary. Now, if the motor is rotating already, then we could decrease the voltage and reach that finely tuned max, or finely tuned power spot, if that makes sense. So that's the problem here. If it's stationary, we need it stationary, right? We don't want it to be, because the reason why I don't think we could have it spinning is because if we launch, or we set the ball up, going up, I don't think it'll take that nicely. Like, you know what I mean? Like, if the wheels are spinning and you put a tennis ball in between the wheels, it'll be difficult to do. Like, it's also dependent on the spring, how strong the spring is. But yeah, that was a completely sidetrack thing. But that may be an issue if we choose this as an option. So, with that being said, if you guys are still sticking along with that, being said, the gravity-fed reservoir seems to be a better option for the tennis shooter. because that way we just basically put a ramp. We put a ramp on it, and then basically just feed it one at a time somehow. So we'll still have to figure out how to send one ball at a time though, because it's gravity fed. To be honest, it might be just a little latch or a door that just goes up and down that stops one ball at a time, or sends one ball at a time. So that's something to keep in mind. And then again, if we choose this reservoir, how is it going to affect everything else? It could affect the position control mechanism. So you start to see how everything's kind of interconnected. Okay. Yeah, don't look at this. That was pretty bad. Okay, so going back to what we were talking about originally, let's give this mechanism a rating. So it kind of already determines what kind of reservoir we might need. If you guys think otherwise, let me know. Again, I'm not the only one that that decides things. We could all come up with something. So what else? Okay, so out of 10, a 7. It's a solid design. Like, it's solid. 6, 7, 6.5. Meet me halfway. We'll say 7. I think it's solid. I think it's a pretty solid design. It's fairly simple, to be honest, and I don't think there'll be too many issues as long as we use a PVC pipe instead of a rail. I think we'll be very, very fine. So I'll give this a 7. Hopefully you could tell that's a 7. I'll put like a, so that's 7. That belongs to this one. Or I guess I could put it next to the name. Oh well. Okay. So a 7. Okay, spring loaded shooter. What is a drawback? What is a pro? What is a con? Whatever. I already saw one drawback is like understanding how to reload the gun. Or not the gun, the shooter, the shooting mechanism. How would you do that? I don't know. I really don't know. Because when this door goes down, right, this will go forward, meaning the string or chain is now loose. You're not going to be able to just put it back unless I manually put it back, and that's no fun. So that's a big flaw. Unless we could kind of design around it somehow, which I can't tell how. Sorry about that. What can we do? We have a door. We have a latch and a spring. How do we do this? Okay, so that's a big con. I feel like that's a very big con. I mean, how do you, I was thinking of like a ping pong machine, but I realized that's a player. Like it's manually operated. But that's really what this is, a little ping pong machine. But yeah, it's just reloading. How would you do that? We could complicate the design, and instead of using a string and a pulley, we could put maybe like a little like linear actuator or like a rail or like a piston to move this back and forth. And then it also has the option to go down, so it could just go back, or to have the spring activate, meaning it'll launch the ball. and then we could just move it. We can move this thing back and forth, so we could reload and load the ball. Jesus Christ, it's so hot in here. God. Yeah, I mean, yeah, I could see that. I don't know. I don't know if that's probably. I don't want to use too many motors, right? I don't want to get it so complicated. Because, again, weight is an issue. Because if we're going to use that design, that's the position control design, we want to keep all the weight. Well, the reason why the weight would be an issue is because if we, again, the torque of the stepper motors, if we don't have the right motor, we could be in a problem. Like, we're restraining our limits of rotation, basically. And, like, if we're gonna have to add another motor and then another mechanism to retract the little latch, it's a little too heavy, I think. At least, I mean, we'll determine that once we start 3D modeling this thing, which is gonna be fun. But yeah, I don't know how. I mean, you could look up how spring-loaded things work. That'd be cool. Spring-loaded gun automatic. It's probably a weird search at this time. Dental automatic crown remover. Yes. Marble spring gun. Here we go. Oh, wow. That is not. God, Jesus Christ. God damn it. What was that? That's not Twitch. That's like TOS for Twitch. God damn, what the fuck was that? That was what the fuck? God. I was browsing as guest too, so I don't know what that was. Wow. Did I say something to like my microphone that caused that ad to show up? What the fuck? God damn it. I clicked full screen too. What the why? I was trying to close it instinctively. I clicked full screen. That was like my monkey brain just seeing like tits for the first time, you know? Jesus Christ. Okay, back to what we're doing. Spring loaded gun automatic device. I should be careful when searching things. Oh, there. Can we just watch it through this preview? It's 8 minutes long. Yeah, okay. Well, we're gonna try it again. Can you guys hear that? No. Okay. Okay, we're back. Okay, yes. How's he? Is it manually operated? I think it is. But we can still use that potentially. Yeah, he's just pushing it back. But he uses like a notch, so that might be easier. Yeah, we could use that, right? We could simulate a barrel and then use like slots and notches or whatever you call it. Well, it's almost 8:30, so I don't wanna rush this. You know, I don't wanna rush. This might be a good design. I don't know. I just don't wanna rush it. We already see cons. Like big cons already. And mostly it's the reloading factor. Not reloading well, reloading the spring factor, not reloading the ping pong ball. So it's already some major issues. So we'll keep that noted somewhere on this thing. It's so cluttered. I'm very sorry for this, but spring reloading issue, and then I'll date that. I'll initial and date that because I'm so accustomed to that. At work we have to initial and date everything we do. It's so annoying, but it becomes second nature. So yeah, okay, I think I'm gonna end the stream there. It's been fun. For those who stuck for the whole stream, props to you. I mean, I would have slept through this whole thing, to be honest. But it has been fun regardless. I realize this looks like a 1, not a 7. Well, I'll remember it's a 7 by doing this. Okay. So, thank you guys for coming and watching the stream. I really appreciate that. Again, I'm going to change my streaming schedule. I was very naive of saying I'm going to stream 5 days a week. It does take a toll on the psyche as well as a lot of work when I'm working full-time as well. So, I'm going to change my schedule starting next week. I'm going to try my best to stick to the schedule of Monday, Wednesday, Friday, 6:30 to 8:30 PT or Los Angeles time. So, hopefully by the end of the year we have something working. Hopefully. I think that's how long it's gonna take. I'm probably being a little generous with that, but I think it's gonna be a while before we start actually building something, because we gotta spec out the parts, we gotta design it, make sure everything will work. But that's part of the fun. And to be honest, it saves time later. So, with that being said, I'll catch you guys tomorrow at the same time if you guys will be watching. If you guys can't catch the stream, it'll be on my YouTube channel. Just for you guys to know, I didn't know this, but if you go to YouTube, if I could browse as a guest, or I guess I can't. Maybe I could do this. If you guys can't find my live streams, this is how you find it, at least on the desktop. I haven't looked on it mobilely. So if you go here, if you go to my channel, you can scroll down. I made a little section for live streams, the last live stream. So they'll be automatically uploaded once I finish streaming. But you could find them there. You could also find it on going to videos, going to uploads, and then going to live streams. And you could find the live streams there. Just letting you guys know, because it took me a while to find that. So if you want to find the archive of these things, they're going to definitely be on my channel. So there's that. Again, thank you guys for watching. I'll catch you guys tomorrow if you guys are going to come watch.